Okay, for this video, we're going to be looking at exponents. So the topic of today will be exponents. Now, if we were asked to evaluate this problem, 4 plus 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 4, we could think about this in a couple different ways. We could start trying to add all these up, 4, and then add another 4 to it, then add another 4 to it, then add another 4 to it. But that could take a little bit of time, and that's time that we don't want to waste. You know, some of us thinking, well, I can just count by 4s, 4, 8. And again, we can do that, but maybe there's a better method. If we think back to the last topic that we talked about, we know that there's a relationship between addition and multiplication. So I know that I could take the number 4, since everything in there is a 4, and I could multiply it by what? Well, I could multiply it by 10 because there's 10 4s there. So I know that multiplication in this case would be a much faster way to solve this, just doing 4 times 10, which is 40, than trying to add up 4 plus 4 plus 4, or counting by 4s, 4, 8, 12, 16. We know that we could use multiplication again to help us out. So if multiplication is an easier way than repeated addition, what if we have a problem like this? 10 times 10 times 10 times 10 times 10. This time we have repeated multiplication. Is there a way that we can solve this in a faster manner than trying to do 10 times 10 and then taking that answer and multiplying that times 10 and taking that answer and multiplying that times 10? Can we figure out a faster way to do this, or is there a faster way to do this? Well, in fact, there is. Because all of these base numbers are the same, all of the factors here are the same, we're all multiplying by 10, I can use something called an exponent. So instead of having 10 times 10 times 10 times 10 times 10, I'm going to have 10 to the 5th power. So looking at this 10 to the 5th, there's a few things that we need to make sure we know. That little 5 right there, that's referred to as our exponent. Okay, our exponent, we can tell, is written smaller than the number it goes with. That number it goes with is called the base. So that exponent is written smaller than the base. It's usually about half the size, and it's written, up in the upper right-hand side, and that has a special name. It's called a superscript. Okay, so if you ever hear the word superscript, that means it's sort of written up like an exponent. And again, we have to make sure we're being very careful when we write exponents, so we don't get the exponent and the base confused or added or brought together. I don't want to think of the number as 105, because if I was to solve 10 to the 5th power, I would see that it's not 105. Okay, I need to make sure I know that it's 10 to the 5th, so the 5 has to be smaller and put in the upper right compared to the base, or 10. Okay, so for these examples, I want us to convert from the expanded form to the exponential form. So those are words you're going to be seeing. Expanded just means it's written all out as multiplication. When we have exponential form, that means we're writing it with exponents. So for letter A, I have an expanded form, 2 times 2 times 2 times 2. So I need to be thinking, okay, all of my factors are the same, so I know that I'm going to have a base of 2, and now I need to think about my exponent. My exponent is how many times that 2 is being multiplied together. Well, it's being multiplied together 1, 2, 3, 4 times, so my exponent is going to be 4. So I could say that this is 2 to the 4th, or sometimes we say it was 2 to the power of 4. Okay, if I look at letter B, I have g times g times g. So if I want to take this from expanded form to exponential form, I'm going to be looking for my base, and I can see that my base is g, because g is what's being multiplied by itself however many times. And now for my exponent, I'm going to see how many times it's being multiplied together. Well, 1, 2, 3. It's being multiplied together 3 times. So I have g to the power of 3, or g to the 3rd power, or if it's the case of a 3, I could say I have g cubed. Okay, it's also important for us to realize that we can have exponents in both decimals and fractions. So we can see exponents not just with whole number integers, but we can also see exponents being used with a decimal and an exponent being used with a fraction. So for these examples, I want us to write the expression in expanded form, then evaluate. So I'm going to write this out in expanded form, meaning with all its factors. Then I'm going to evaluate, which means I'm going to actually solve it. So if I have 3.8 to the fourth, that's the same thing as saying 3.8 times 3.8, there's 2, times 3.8, that's 3, times 3.8, there's 4. Again, my exponent was 4, so I need to make sure I had 3.8 written 4 times. 1, 2, 3, 4. And now I can go ahead and I can multiply those. And when I do, I end up getting 208.5136. So there's my answer when I evaluated. For letter B, I have 1/2 to the third power. So that's the same thing as saying 1/2 times 1/2 times 1/2. Now when I go to multiply, I have to remember how I'm multiplying fractions here. When I multiply fractions, I just multiply straight across the numerator and straight across the denominator. So for my numerator, 1 times 1 times 1 is 1. For my denominator, 2 times 2 times 2, well, let's break this up. 2 times 2 here is 4. And then 4 times 2 is 8. So I end up with 1/8. Okay, a couple terminology here. One I already touched on. The other one I haven't yet. The first one is squared. If I'm saying that a number is squared, like 5 squared, that just means that it has an exponent of 2. So if I'm saying, again, 5 squared, that would be the same thing as saying 5, 2, or an exponent of 2, 5 to the second power. So again, that's like saying 5 squared. Okay, anything with the exponent 2 we usually say is squared. Likewise, if we have something cubed, that means that it has an exponent of 3. So if I say I have a number cubed, like 5 cubed, that's saying 5 to the third power. Now, it's not wrong to say to the second power or to the third power, but you should be aware that if you see it written out as something squared or something cubed, that means the second and third exponent. So to wrap it all up here, we use exponents as a quicker way to multiply if the factors are the same. So we can only use exponents if the factors that are being multiplied are the same number. So if I have 2 times 2 times 2, I can say that is 2 to the third power, or 2 cubed. If I had something like 2 times 2 times 2 times 3, I can't write any of this as exponents because not everything is the same factor. I can see that I have a 3 here that's different, so that expression cannot be written with exponents. They have to have the same factor. And the amount of factors that we have are going to tell us what our exponent should be.